Okay, well, hello and happy Wednesday. I hope your first week is off to a good start and things are well, and I appreciate all of you being here. I especially appreciate those of you who turned on your cameras. You are already my favorite students. I'm just kidding. But I do appreciate you turning on your cameras, those of you who are willing to do so. And then when we meet in person, I always appreciate those of you who sit near the front because I can always, it's easier to see your faces in the front. It's weird, right? There's probably a correlation between who turns on their cameras and who sits in the front anyway. But um, but anyway, that's I'm able to I like interacting with students and stuff. So let's get started. Okay, so yes, I did post a homework assignment already, and some of you guys already gotten started, which is great. And if you haven't, that's totally okay. We haven't really even talked about R or anything like that. So let's just talk about getting your R set up in a in a good way, I would say. So what I recommend is when you download those homework files, first of all, create a little folder on your computer. Create a folder for homework 1. Create a separate folder for homework 2. Create a folder for homework 3. Okay, create separate folders for each homework, and then put all of the relevant files in that particular homework folder. So for homework 1, download the files, put it in homework 1, and then when you are working on that particular assignment, so let me navigate over to there. So for this class, okay, so I've got a whole bunch of extra stuff. So this would be like kind of my homework 1 folder, and you'd have your kind of your output file, and you would open this up here. Let me zoom in a little bit for you guys. When you open it, you would go to Session, Set Working Directory to Source File Location. Okay, Set Working Directory to Source File Location. All right, so when you do that, you go to Session, Set Working Directory to Source File Location. And that way, all of your commands will be referencing files within this folder. Oh, I have under Global Options, you can change, under the Appearance, you can change kind of your theme. And I think that, I don't remember what the default is. The default is this. I use a dark theme, this, but whatever, okay? Your default is probably something like that, and you can change your appearance under Global Options, appearance there, if that's what you want to do. Okay, so anyway, that's your working directory. If in one of the problems you have to reference this this file, monthnames.txt, and if you don't have your working directory set correctly, you're going to get errors like, I can't find this file name, can't open the connection to monthnames.txt or something like that. Okay, so that should be the first thing you should do. Another thing is, every time you start working in R, you want to work with an empty environment, okay? Because as you work in R, you're going to be creating little vectors and stuff like that, and things will end up in here, and sometimes these things can mess up what you're trying to run. So I always recommend hitting this little broom. The little broom is going to delete all this stuff, clear out of your environment. Okay, you're going to end up with it. Environment is empty, and that's what we want to see when you get started on a project. So hit the little broom icon. Okay, if you want to remove just one variable at a time, you can do that also. Right, so let's go ahead and so here I've got these things. You can change from list to the grid, and then you can select the one thing you want to delete. and you check mark it and you hit the broom and it will delete that one thing, okay? But otherwise, I just like to hit the broom and delete everything sometimes, okay? Obviously not in the middle of what you're working on, but when you start, you should start fresh. Start by deleting everything out. Here's another way you can click, you can type in the command. The command is remove, list off everything in LS, and that will remove everything in the environment, okay? Oh, another recommendation, very strong recommendation here. When you work with RStudio, under global options, you're going to go to tools, global options. And under general, you've got workspace. There's two things you should have here. Okay. One, don't have this button checked. Okay. Restore our data into workspace at startup. Leave that unchecked. And then change this. Say workspace to our data on exit. Never. All right. That's my recommendation. Okay. Because what happens is you'll be working, and if you save your workspace, it'll save all of your stuff, and then when you open it up, it's all there again, and you go, oh, this is great. It's just kind of like picking up right where I left off. Well, sometimes you have to restart your computer. Sometimes things don't pick up, and therefore, never saving stuff forces you to be intentional about saving your data and being intentional about kind of saving the data that you want to keep and intentionally restoring the data you want to restore, because sometimes things go wrong. And if you are kind of relying on the computer to do all of the saving for you, sometimes you can get lost. You can be put in a state where you're not quite sure how to recreate the stuff you have. Okay. A lot of times people run into issues where they try to knit a file, and when they knit a file, it doesn't work. Okay, I often hear this complaint. Everything's working on over here. I can run the code chunks, right? But then when I try to knit it, I can't knit it. Okay. Well, what happens when you knit it? R basically starts up an empty machine and tries to run all of the code, right? It's intended to be reproducible, meaning you can give that markdown file to someone else, and then they can knit it and it will produce it, right? So what R does, because that's the whole kind of point of this markdown business, is reproducibility. It starts off with an empty machine and it tries to run all of the lines of code. Now it runs on your machine because your machine probably is not currently empty. There's probably stuff in the environment, right? And your code is working because it's referencing stuff that exists in the environment, right? And you can click the little button and it's running, okay? Because there's stuff here and it's working. But then when you knit it, it's not working, because when you knit, it's working with an empty environment. So what I like to say is, well, what if you deleted everything in your environment and then you try running your code? Okay, if you deleted everything in your environment and you try running your code, you're probably going to run into the exact same problem that's coming up when you're trying to knit and it's running into problems. Okay, and by forcing you to do that, you realize, oh, in my code, I'm referencing this value K that I never wrote the instructions for creating K in the assignment. Okay, I created it down here in the console when I was working here, and so it ended up in my environment, but I never created the instructions for creating K in the instructions. So I need to add that line of code to do that. So that's going to happen. So this just kind of, using these things put you into good habits of being explicit about creating values, being explicit about when you're going to save your stuff and things like that. Okay. So that's all of this. A couple of shortcuts. You can turn on comments. You can quickly comment lines of code. You can just highlight them. Command-Shift-C or Control-Shift-C will comment those lines of code, toggle them on and off. Okay. You can always type out the hash mark there as well. You can always create new scripts in R, Command or Control Shift N. You can run blocks of code, okay? And you can hit this little button, this little button here. This will source this file here, or this will run whatever's in the corner. Okay, you can also click this button, like as you're working down later and you want to run everything above it, you can click this button that will say run all chunks above. Okay, and then you can run that particular chunk of code, right? If you want to. So you got all kinds of stuff there. So these are just little shortcuts that I think are helpful. I encourage you to review these notes as you start working in R&R Studio, or as you continue working in R&R Studio, and just kind of familiarize yourself with these things. I think this will make you a little bit more efficient as you're doing things. Okay, a few things: clearing the console, knitting, and restarting. These are some command shortcuts that I frequently use. So clearing the console, you can hit the little broom. Sweep will clean up the console here. But again, as things get cluttered down here, you can also just hit Control L and that will clear it out. And if you want to knit whatever you have, you can always click the knit button, or you can hit Control Shift K or Command Shift K. Okay, let's go ahead and get started on talking about data structures. Now, I know you guys covered data structures already in Stats 20, but I want to kind of get a little bit into some of the nitty gritty. And these first couple lectures will serve as like a quick whirlwind review of Stats 20. For some of you, you took Stats 20 last quarter, so a lot of this stuff is fresh. And some of you, you took Stats 20 maybe during your second year, first year, and now you're now it's been several quarters since then, and so you've forgotten a lot of these things. And you know, it's always my hope and dream that after you take Stats 20, you fall in love with R and you keep coding R every single day. But I also know reality is not always what I dream of. And so if it's been a while, you know, hopefully these couple lectures will just get you back. I don't know, maybe not with a snap of a finger, but we'll refresh some of these ideas here. Let me go ahead and give you your first view quiz answer for today, which, oh, I forgot. I have to look it up. Give me a second. 102A. Oh, today's slides have not been posted. You are right. I forgot to do that. Okay. First view quiz answer today is A. And let me post today's slides. I apologize. Thank you for just trying to keep track of all sorts of different stuff. Okay. So week 1 Monday, or week 1 Wednesday. Okay, week 1 Wednesday. All right. Okay, today's slides have now been posted onto Canvas, and so they are there. Okay, so the slides are there. All right. So what's the main difference between an atomic vector and a list? Do you guys remember the main difference between an atomic vector and a list? Okay, well, thank you for participating here. The difference is that an atomic vector, all of the values in the atomic vector have to be of the same type. Whereas in a list can have different types, right? A list can combine characters and numeric values and things like that. Atomic vector, you've got basically 6 types of values. And really, we only work with 4 of them on a regular basis. And so you got your logical, those are your Booleans, your true falses. You've got double, which basically have decimal points. You have integers, which don't have decimal points, and characters for anything that's got strings. Okay, complex and raw also exist, but that's what we have. And atomic vectors have to contain all of the same data type. R will automatically switch, convert between integers and doubles and things like that. So you often don't need to worry about it. They're both kind of numeric types. Doubles are stored with floating point precision. Integers are stored as exact values. The default numeric type is type double. If you want, like if you type in the number 3, that's a type double 3. If you want a number 3, you want to type in the number 3 and you want it to be an integer, you can use the capital L after the number. And also when you use the colon operator and kind of create a sequence of numbers, it's also going to be integer type. So if you create a vector 1, 2, 3, that's going to be type double. But if you do 1:3, that's going to be type integer, right? And we can learn about the types using type of. Is double is going to be true for 1, and is integer is true for 1L. 1L is going to be integer type. As far as lists go, lists are more flexible, and they can contain other stuff, including other lists. We can arrange our values. Generally, if we just kind of have like a train, a sequence of things, that will just be one-dimensional, but you can put some structure to it. With a matrix, you can have a 2-dimensional, basically atomic vector. Atomic vector in 2 dimensions will be a matrix. All the values in the matrix have to be the same type. You can also kind of take a list and make a 2-dimensional structure, and you basically have a data frame. You have columns of different types, 1 column of numbers, 1 column of character data, 1 column of integer data, things like that. And you can have even higher dimensional things, right? You can have like an array, a 7 by 8 by 10 array, a 3-dimensional structure, but that only exists for values of the same type, like a matrix or an atomic vector. Question, can you use x equal 2 and say xl to denote integer? No, that's not going to work, okay? So it has to be x equals 2l. You can do x as dot integer x, that will work, as dot integer x, but you can't, using the L there is not going to work as a shortcut. All these vectors can have, not necessarily do have, but they can have attributes, okay? An attribute is, the attributes are stored in a list, and it's just totally arbitrary information, okay? It's basically like you've got the object, and then you can staple a piece of paper, and on that piece of paper, you can write whatever you want, right? And so it's kind of just like some extra information that could be useful. So there are certain important attributes that are necessary. So if you've got a matrix, the matrix, one of the attributes a matrix will have will be dimensions. It'll say something like this matrix is a 5 by 7 matrix, right? The dimensions of the matrix. If we are dealing with object-oriented stuff, which we will talk about later, there's the S3 object-oriented system. You'll have things like the class. This is a factor. This is a data frame. That's object-oriented information, and that class appears attached to as an attribute. Okay. I've put in a few questions to quiz yourself as you study later, right? Okay, so you can answer these questions. Maybe you can answer these later. So if you want to get the attributes, right, you can use the ATTR, okay? And that will access one particular attribute, and it can also be used to assign or set the value of one particular attribute. If you want to just see all of the attributes associated, you can just type in attributes, okay? So for example, there's a data frame, trees. Okay, this is just kind of one of those built-in data frames, all right? And we can ask, what are the attributes of trees? Okay, and so it's a data frame. And so when you ask, what are the attributes of trees? It comes with 3 attributes. the class, it's a data frame. And then it says, oh, you've got 3 columns here. Okay, the names are the names of the columns. You've got the girth of the tree, the height and the volume of the tree. And then the rows have their own names, and we've got the names of the rows are just basically numbers. And we've got basically 31 row names here. So this is the attributes of the tree. One thing that a data frame doesn't have, if you ask, what are the attributes? Is there a dimension attribute? There's not. For a data frame, there's no dimension attribute. Okay, but you can ask like, hey, what are the dimensions of the data frame? And it will tell you it's 31 rows by 3 columns, but there's no actual dimensions attribute. Okay, which it gets these dimensions by looking at the row names and the length of the column names, and says, oh, you got 31 row names, you got 3 column names, therefore it's a 31 by 3. Okay. If you want, you can add additional attributes, right? So using the attr function, I can say, I want to create a new attribute called info. And this, again, it's a list. You just write whatever you want. So here I just write, hey, this data frame's about trees. I'm really excited about this, okay? And this is not typical, not normal practice, but you can do it if you wanted to. With a matrix is really just an atomic vector with dimensions applied to it. We'll try to make this huge. Okay, so here I'm going to create a vector m. M is just a vector 1 through 10. And if I say, hey, what is the class of m? Okay, it's just going to say, oh, it's an integer vector. It's an integer vector. But what you can do is you can say, all right, you know what? I want to set the attributes of m. I want to set the dimension attribute. Let's make it a 2 by 5. Give it the dimensions 2 and 5. Okay. And now m is a matrix. M is a matrix. 1, 2, 3, 4. It fills it out by the column. And if I say class m, it's going to say, hey, you know what? This is now a matrix. I recognize this. This is now a matrix. Okay. And you can say, what are the attributes? What are the attributes of m? It's going to say it's got dimension attribute 2 by 5. All right. And again, m is a matrix. Now we could take these. The dimension attribute is this. I could set this null. I can delete this out. And now there's no dimension attribute. And what is m? M is now back to an integer vector. So you can take an integer vector, you can apply dimension attributes, it becomes a matrix. You take away the dimension attributes, and now it is back to being just a vector, right? So it's a little bit like, it was the same thing all along, right? 1 through 10, just the numbers 1 through 10. The data is still the same. We never actually changed anything to the data, the values in there. All we did, we just said, hey, let's just reshape this. Oh, look, it's a matrix. Okay. An array is basically the same thing, just with more dimensions. So this is a 2 by 3 by 2 array. So 2 rows, 3 columns, and 2 layers, I guess. I don't know. What do we call this thing, right? So now it's like a rectangular prism, a 2 by 3 by 2 kind of grid, solid something. Okay, 3-dimensional object, right? And you can even have more dimensions. You can have like a hypercube or something. Okay, in higher dimensional space. It gets hard to think about, but if you need to store it that way, you could. Okay, notice the kind of the prefixes, right? So if you wanted to get the first row, it's 1 comma. You want the first column, it's comma 1. And if you want the first layer, it's comma 1. Okay. So row, column, layer. Let's give you your second view quiz answer, if I remember. Second view quiz answer is B. B as in bear. B as in bear. B as in brew and learn. Okay. Well, we got data frames. Data frames internally stored as lists, right? That's how we allow it to have different types of data, right? Because lists allow us to have different types of data. And a data frame can have different types of data. You can have different columns of stuff. And basically, to kind of make sure that it can remain 2 dimensions is that the lists, the columns, all have to be of the same length, right? Otherwise we'd be running into trouble. So if I say, hey, give me just the first 4 rows of trees, I can say, you know, trees, I want the head of trees, I want the first 4 rows. And so we can see, okay, we've got 3 columns. And as far as this goes, they're all just kind of numeric columns. But the class of the trees data frame is that it's a data frame. But if you ask type of, it's a list. It's a list. Meanwhile, we have a factor. Okay. A factor is, how is a factor stored? Okay. Internally, a factor is an integer vector. Okay. A factor is used to store categorical values. So if you think of, you know, maybe here's a gender factor. Okay. We have M, we have F, we have X for, you know, maybe non-binary. And so we have different categories that, you know, we're trying to apply. And basically what happens is these get coded. These get coded, right? I think R is going to say, well, alphabetically, it goes F, then M, then X in the alphabet. So F is going to be factor level 1, and M is going to be factor 2, and X is going to be factor 3. And so internally, this is actually going to be the values 2, 1, 1, 3, 2, 1, if I did that correctly. Okay. And so if you ask, hey, what are the levels? The levels are F, M, and X. And internally, these values are stored as integers. Internally, it's stored as integers. So, so if you say, hey, let's take this thing, let's take this factor and convert it to integer type as integer, it's gonna, yeah, it's gonna give us 2, 1, 1, 3, 2, 1. Okay. And basically when you display it, R says, oh, you know what? I remember the 2 stands for M, and the 1 stands for F, and the 3 stands for X. And this is what we get. Okay. And if you ask, hey, what are the attributes of the factor? You've got 2 attributes. You've got the levels, and you have in its class as a factor. So weird things could happen because of the way this is stored. Okay. Here, if I take the values 0, 1, 10, 5, okay, 0, 1, 10, 5, and I say, let's make a factor out of it. Okay. Now I've got X as a factor, 0, 1, 10, 5. And these are the levels. The levels are 0, 1, 5, 10. And I could say, hey, what's the mean? What's the mean of 0, 1, 10, 5? And you go, okay, 0 plus 1 plus 10 plus 5, that adds up to 16. You got 4 numbers. The mean should be 4, right? But you try to take a mean of a factor, and what it says, hey, you can't do that. You can't do that. It gives you back an NA. I go, I can do this. I can do this. So you say, well, let me turn the factor into numeric. We can do as numeric factor, right? And ask, what's the mean of this? And it gives me back 2.5. Gives me back 2.5 rather than 4, right? We go 0, 1, 10, 5 adds up to 16, but the mean comes back 4. What happened? Okay. Well, when you do as numeric, internally, it's stored as 0 is stored as 1, 1 is stored as 2, 5 is stored as 3, and 10 is stored as 4. Okay. These, remember, when you have a factor, you are saying this is a categorical variable. So it's kind of like product numbers, right? Or product model, right? What is, oh, you're getting, which toaster are you getting, right? Oh, I'm getting toaster PV, PV0 or PV1 or PV10 or PV5, right? These are like toaster model numbers, okay? And it's like, oh, what's the average toaster number? That's like a nonsense question, okay? We don't take these factors, these category, and ask for an average or something like that, right? If you think about like your area code on your phone number, it looks like a number, but it's not numeric information, right? So it doesn't make sense to say, oh, you know, when I was growing up, my area code was, 661, and then I moved to this city, and now my area code is 213. And therefore, my average area code over my life is, I don't know, 457 or something, right? It doesn't make sense to talk about average area code. You don't say, oh, my area code is bigger than yours. That doesn't make sense, okay? So just because it's a number doesn't necessarily mean it's got numeric value, right? And so that's what's going on. When you tell R that these numbers are a factor, it's going to treat them as categorical values, right? And that's why it's saying you can't ask for the mean of a categorical value. They're basically model numbers, okay? You don't ask for the mean of, something like that. Okay? And so if you try to do weird things with factors, like these are things you should never do, that you get weird stuff, right? So if you concatenate, if you try to combine a factor AB and BC, it doesn't know what to do, right? It internally stores this as integers 1, 2. It internally stores this one as integers 1, 2, and you combine them, you get 1, 2, 1, 2. That's not going to work, okay? And then if you've got a factor, with values, levels f, m, and x, and you try to insert some value that doesn't exist, okay? It's going to generate an NA. When should data be stored in a factor over a vector? So a factor is a vector, but it's a vector of integer type, and it's for categorical variables. So if you have kind of like, there's only a certain type, like only certain categories are allowed, then it makes sense to use a factor. Okay, if you want to kind of say, we're going to make sure everything kind of fits in a certain category, then that's fine, right? You can say a person at UCLA is either a student or a staff or a faculty, okay? And you've got categories, something like that, okay? Question, why doesn't as.character convert factors into 1, 2, 3, 4? They do. So if you wanted to, I'm sorry, so this will work. So you can take 0, 1, 10, 5. 0, 1, 10, 5 is going to convert. If you do as.character, it will convert to character 0, character 1, character 10, character 5. And then you do as numeric on those characters 0, 1, 10, and 5, and it will turn it into the numbers 0, 1, 10, and 5. And then now you can take the mean, and it will go 4. Okay, so if I break this down, this takes the factor 0, 1, 10, 5 and turns them into the characters 0, 1, 10, and 5. And when you do as numeric, it turns them into the numbers 0, 1, 10, 5. If you go as numeric straight on the factor, it goes 1, 2, 4, 3. Break this out into individual steps, and I think you'll understand what's happening. R does coercion, okay, automatically. And this is one of the things that I think make R a nice language to work with, but it can also be frustrating for like someone with a CS background, because this is like breaking a lot of CS rules, okay? So for the statistician, R is great, right? So R is a language designed by statisticians for statisticians, and that it does a whole bunch of stuff. So you don't have to worry about like, memory management and stuff like that. I don't know if you ever took like a C programming course or something like that, but you got to like worry about like memory leaks and like making sure you kind of delete all sorts of references to memory and things like that. And you don't have to worry about that in R, okay? And it does a bunch of stuff for you. And one of these things is coercion. And if you understand how the coercion works, it's not a problem. But if you don't, then it can result in like surprises, okay? So here I've got L, which will be a logical vector, true, false, I, which is an integer, D, which is type double, and CH for character, okay? And basically R is going to, when you create an atomic vector and you combine stuff together into an atomic vector, everything has to be of the same type. So it's going to coerce everything into the same type. So what happens when I combine the logical, the integer, and the double? Okay, well, it's going to look at the least restrictive type. Okay, so I've got logical, integer, double, character, list. The least restrictive type is double, and it's going to coerce everything into type double. So that logical, the true, false, will get coerced. Logical as a double will be a 1, true will become 1, false becomes a 0. So the logical becomes 1, 0. The integer remains 1, and 5, 6, 7 remain type double. And when we ask what is this type, it's type double. If I combine the logical, the integer, and the character, it coerces the logical straight into character. And so that true, false becomes true as a character value and false as a character value. And then it combines, the integer becomes character 1, and then the character values AB remain character values AB. How would you make this a generic vector so that it doesn't coerce? Okay, well, the only way you can do it is you create a list with a logical component, a list with a double component, a list with a character component, and it will be 3 separate vectors in one list, okay? What does a value such as 1L mean? 1L back here is an integer number 1, okay? Or if I just typed in 1, it would be a double 1, allowing for decimal values, whereas 1L means it's an integer and there's no decimal. Things just will get coerced kind of implicitly. You don't even have to ask R to do it. R is just going to do it. It's going to say, all right, you want me to do this? I'll do it. Okay. So if you have a logical vector, false, false, true, these could be the results of some experimental trials. You can say, you know, if you say I want these to be numbers, you can do as numeric on the trials. The false becomes 0 and the true becomes 1. So you would get 0, 0, 1. But you don't even have to do as numeric trials first. You can just say, hey, trials, give me the sum. What is the sum of false, false, true? The sum of false, false, true will internally, it's going to convert them into numbers, 0, 0, 1, and then give you the sum. 0 plus 0 plus 1 is 1. And if you say, hey, what's the mean of this vector, false, false, true? It's going to convert it to these numbers and then ask, what's the mean? What's the mean of 0, 0, and 1? It's going to be 33%. And that's basically going to be the proportion of truths. Okay. I think you guys have seen this already, right? You've seen stuff like this. It's just putting this on a slide. So you can explicitly coerce things. You know, you can say, I want it as character. I want it as logical. I want it. You can do stuff like that. So as far as the values, character just puts everything, quotes around everything. Logical, zeros become false, ones become true. If you try to coerce something that R doesn't know what to do with, like take the word cat and make a number out of it, R is going to say, I can't do that. Okay, it's going to give you a missing value. So for logical, the thing is everything that's not a 0 becomes true. Okay, with except not a number, nan becomes na. All right. So 0 becomes false. Everything else, 1, -1, 0.1, 2, negative infinity, something really, really, really tiny, but not 0. Okay, those all become true. And then nans become na. As numeric cat doesn't throw an error. It just says that it's not an error. It just says I don't know what this is. Okay, it's just a missing value. Right. Generally, R doesn't want to throw errors if it doesn't have to. So if it can just say, hey, you know what? You asked me for something and I don't know what the answer is. I'm going to just tell you I don't know what the answer is, rather than throwing an error. An error will force your code to stop running. Whereas a missing value, maybe you can keep working. Okay, these are accepted spellings of logical values. Okay, so you can capital F will become false. All caps false becomes false. Capital F false. Lowercase false becomes false. These are accepted spellings for true if you want to make them valid. But if you do something like lowercase f, try to make it logical, it's going to say, nope, can't do it. T, it's not going to work. Okay. Hey, what happened here? Why didn't the 0 and the 1 become false and true? It worked back here. Why didn't it work here?
It got coerced to characters.
It got coerced to character. That's exactly right. Okay. So when we combined the 0 and 1 here, this became character 0 and character 1. Okay. Character 0 is not going to coerce to false or true. Okay. The numeric value 0 and the numeric value 1 will coerce to false true, but the character 0 and character 1 will not. Okay, good. Okay, special values, NA, null, and nan. Okay, the answer here, NA is for missing values. Okay, null is for things that do not exist. And nan is a numeric value, or it's a type double numeric value that we can't represent, or maybe we don't know. Okay, it's an unknown unknown number. Okay, unknown number. So here's maybe so maybe the difference. Okay, so we could have let's say you have a person. Okay, and we say, hey, how much does the person weigh? Okay, maybe you don't know the weight of the person. The person's weight would be an NA. This is a missing value. It exists. The person, if a person exists, this person has a weight. Okay, so you don't want to, you're not going to use null because the weight does exist. We just don't know what it is. Okay, so you use NA for something that exists, but you don't know what the value is. On the other hand, you use null for things that don't exist. So perhaps you have, for person, maybe you have a column for like a partner. Okay, so maybe a romantic partner or spouse or something, right? So we could have a person's weight and we can have partner's weight. Okay, so if the person's weight perhaps is unknown, it's NA, right? If the person does not have a partner, then the partner's weight would be null, because then that weight does not exist. Okay, there's no partner. If this person doesn't exist, there's no value there, right? If the person does have a partner, but you just don't know the partner's weight, then you would write in NA. Okay, does that make sense? The difference between an NA and a null? So null is for something that doesn't exist, whereas an NA is for something that does exist, but we don't know what it is. Okay. Who wrote that's pretty sad? Are we talking about the partner not existing or something? I don't know. Okay, maybe we'll say cat. Okay, person and their cat, and maybe the person doesn't have a cat. Okay, there is an NA for every data type. Okay, so adding an NA to an atomic vector is not going to change its the type of vector, right? So if you have a logical vector and you put in an NA, then it's gonna remain logical type, right? So this is a type logical, right? But you also need to have NA for integer type and you need to have NA for double. Double would be real, and NA for character. So you have an NA for each type. Don't ask NA is equal to NA, right? If you want to know is something equal to NA, you're not going to get an answer. Okay, you can think of NA as like mystery box. I have a number in this hand, but you don't know what it is. I have a number in this hand, you don't know what it is. Is the number in this hand equal to the number in this hand? Your answer? I don't know. Okay, so the answer is going to be NA, right? You can say is NA is just is the number unknown? What's the number in my hand? Is it unknown? Yeah, it's a mystery to you. That's going to come back true. So you check for NA's using is NA. Oh, okay, I got to hurry up. Okay, null is for why does negative infinity course to true if it's not a number like nan? Okay. Because that just means we had a value. We have a value for it. Negative infinity, like we have an idea of what it is, right? It's going off to infinity. And it's not a missing thing. It's infinity or negative infinity. That's going to course to true. Basically, that's just the rules as far as coercion go. Okay. Null is its own type, again, used for values that do not exist. So type of null is the null type. It's its own type. Is it null? That's going to be true. If you say, is it missing? Is NA gives you back a logical value, true or false. But in this case, it's going to give you logical zero. Logical zero means it's a logical value of zero length. So it's asking, there's nothing there, right? So it can't even answer it. Is it missing? It's just, the thing doesn't even exist. Okay, is it type? Is it logical type? It's not logical type. It's a null type. Okay, and if you try to do any kind of operations with null, it just doesn't work, right? If you try to add something together with null, you get a zero length vector. Why did I get an integer here? False is logical type, null is null type. There's implicit coercion with the plus. The plus coerces the false into an integer. And then we're trying to add null to integer 0, but then, or the 0 value, and then it gives me back an integer vector of length 0. If you try to insert a null inside a vector, it doesn't exist, right? This is something that doesn't exist, so it doesn't get, right? And you can't do comparisons with null values. All right, I'm going to run out of time. Just kind of, you're going to have to look at these last few slides on your own. But I think we're accustomed to this by now, maybe. Okay, vector, some arithmetic is vectorized in R. So 1, 2, 3 with 100, 200, 300 becomes 101, 202, 303, things like that. They add together. The first gets added to the first, second to the second. There's recycling, right? So when I do 1, 2, 3 plus this thing, the 1 gets added here, the 2 gets added here, the 3 gets added here, 1 gets added here, 2 gets added here, 3 gets added here. And it works for both of these things. For the second one, it's going to say, I'm not sure if that's what you wanted me to do. Okay, so R is like the eager dog that is happy to please. Okay, and it's going to try to do this thing, but then it says, you know, I noticed this thing has length 3 and this thing was length 5, and so I ended up with a 500 and the 2. I don't know if that's what you wanted me to do. So it gives you a warning, but it says, but I did it. I hope you like it. And you go, oh yeah, good job, R. Okay, it just wants your approval. The same thing applies when you are doing recycling with a matrix. Okay, it recycles vertically. Okay, it recycles vertically. So here I created a matrix 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But down the columns, if I'm going to add 100, 200, 300, notice the 100 gets added to the first 200 here, 300 here. Then it goes 100, 200, 300. It gets recycled column-wise. If you want it to go across the rows, what do you have to do? You have to transpose it, and then you can add it column-wise, 100, 200, 300, 100, 200, 300. And then you transpose it back, and you get it back this way. Okay. Did I give you your third view quiz answer? No, I haven't. Oh, I'm sorry. Okay. Your third view quiz answer is E. E as in elephant. E as in elephant. And that's it. Okay. So we will end here for today. And we will see you guys on Friday. So have a good day. And don't forget to take your view quiz, and we'll see you guys on Friday.